afternoon and welcome to the show. I'm Flyzik. On today's show, we will discuss how the explosion of data, so-called big data, is being addressed in government programs. With me today on the program are Alan Hansen, Chief Intelligence Systems and Processing Division at the U.S. Army, Zach Goldstein, the Deputy CIO at NOAA, Adrian Gardner, CIO NASA Gardner, Dr. Robert Norris, Chief Architect, NGA, Cameron Chehreh, the Chief Enterprise Engineer, Intelligence Solutions Division, General Dynamics IT, John Haddad, the Director of Enterprise Data Integration, Informatica Corporation, and Gary Newgaard, Area Director at EMC Isilon. Let's get into the discussion. Let's start with Adrian Gardner over at NASA Goddard and talk a little bit about Adrian. Tell us how big data is impacting programs over at Goddard.
So NASA, in particular, my center, Goddard Space Flight Center, I mean, we host the largest number of scientists, engineers, and technologists in our area of studying the Earth, the Sun, the solar system, and the universe. And our satellite capabilities and instruments are actually produce large amounts and massive amounts of big data. So really, if you look at NASA's mission, our whole part of our mission of our center is actually big data in itself. Mm-hmm. So massive amounts of data around astrophysics, heliophysics, so on and so forth, studying for looking for the future of life in the cosmos and the universe.
Yeah, I can see where when you think about who's on the show, you know, NOAA, NASA, NGA, and Army, you can just picture those entities having massive amounts of data in the collection of scientific evidence. Dr. Norris, Bob, over at NGA, tell us a little bit about how big data is impacting your agency.
Well, for your viewers, NGA is a combat support agency that's rather unique for the federal government because not only do we have a combat support role, but we also have a humanitarian assistance and disaster recovery role too. So, for example, our agency was helping with the Japanese tsunami project, also the tsunami down in Indonesia, as well as the role that we play with the military over in Afghanistan. So we have very large data files, like you would expect as far as imagery is concerned, and things like that.
Yeah, Gary Newgaard, I guess when we think of EMC Isilon, we think of storage, but I would imagine with this explosion of data, the challenges are there too. But tell us a little bit about how you're positioning to help government agencies and what kind of impacts this will have at EMC Isilon. Well,
that's good afternoon. So what we're seeing is an absolute explosive growth in unstructured data. So it's digital images, digital video, audio, computer models, simulations, scanned documents, and it's not too different from most of your audience's personal computer. The amount of data on their personal computer that involves columns and rows is significantly shrinking. It's not growing near as fast. The amount of images that we ingest on a day-to-day basis, whether it's at NGA or NOAA, are growing at 67% compounded annual growth. So the government and industry are forced to deal with this in a more economical manner, dealing with the budget reductions that we all have to do. So doing more with less and getting a predictable cost model is really what's driving the market.
Sure, and you know, and looking at the projections, it looks like there's no stoppage in this. This trend is just going to continue and continue, so it's going to be constantly a challenge for all of us. We'll get into challenges a little bit later on. Zach Goldstein over at NOAA, how is big data impacting you guys? I guess when I think of NOAA too, I think of massive amounts of satellite data and imagery and so forth. But tell us a little bit about what's going on over there.
Well, similar to what Adrian was talking about at Goddard, NOAA is a big data agency. It's what we do. Most of our programs depend on big data. We all know about the weather satellites, but we also have radar systems, weather balloons, ocean buoys. We process them in supercomputers to allow the National Weather Service to give you a forecast. But it's not just weather forecasting. It's also global climate modeling, mapping the ocean floor, and ocean currents. Predicting the course of an oil spill is a big data problem that you probably remember when we had a spill in the Gulf. To get an idea of the massive numbers we're talking about, I did some recent checks. Just one of our supercomputer modeling systems runs on 30 petabytes of data.
Wow.
12 petabytes of new data are added per year. With our latest satellite being launched, we're ingesting 4 terabytes of data per day into our large archives. And here's an interesting fact. As the hurricane was approaching New York City last year. At the peak, our web farm served up 2.8 terabytes in the hour approach as the hurricane was approaching.
Wow.
So it's everything we do.
Wow, we're going to need new names for this, terabytes, petabytes. So we're going to start thinking of new names for things, unless you guys already have thought of all that stuff. Yottabytes? Is that as far out as we can go? All right, well, let's go to Cameron over at General Dynamics IT. Cameron, how are your company positioning to support government, and how's this impacting you?
It's having a very significant impact, Jim. And I tell you, from an industry or systems integration perspective, for us, it's about how we manage the data to create a positive result of actionable intelligence and knowledge. So for us, it's how do we manage our process, our people, the capacity and skill sets, the infrastructure to be able to accommodate what the mission outcome really is. It's a very different way of thinking in recent days, focusing more on the mission segment, whatever your mission may be, and how you derive the outcome from the data.
Yeah.
What is the knowledge or the information you're really looking for?
Yeah, we'll get into some of that. I know the analytics and things like that, dealing with these massive amounts, like Gary mentioned, it's not only not structured anymore, you got all that unstructured stuff. It's going to make it very interesting issues. Alan Hansen over U.S. Army, how is big data impacting you? We know about all the volumes of data that the Army deals with in so many different areas, but give us some ideas.
Sure. Specifically, we've, over the last few years, we've had multiple, we call program of records, systems that we deploy on the battlefield, and each of these systems themselves produce this massive amount of information. Well, we come to this crossroad where we have to bring this information together and then serve it up to massive users as well. And one of the big powerful thing about doing that is that we're bridging this information to multiple users and putting analytics on top of this information that allows us to do things like pattern of life analysis, knowing what our enemy's doing.
Yeah, I can imagine, just imagine the volumes of data. John Haddad over at Informatica Corporation, how's Informatica positioning to support the growth in the big data here? How's it impacting you?
Well, we're seeing some emerging technologies such as Hadoop, which are really breaking down the barriers in terms of time and cost, right? So when I listen to the other panelists talk about the massive amounts of data that they're managing and dealing with, how do you integrate that information to gain insights and to turn those insights really into something of value? So the possibilities are endless. I'm listening to all our different speakers here give us, their situations, but a few that I noted across various agencies is for example, the FAA is looking at moving air traffic in a more efficient way and reducing delays in fuel usage, right? But this requires sharing flight status information combined with weather information. And, doing better weather predictions, climate analysis requires gathering satellite imagery data, combining that with, all types of other information. Similarly in healthcare, right? Trying to determine better patient outcomes. Looking at patient records and medical records, but managing the security. So addressing, the ability to access all this information, integrate it, and then make sure it's secure and available so that you can, process this massive amounts of data using some of the emerging technologies that we're seeing.
Yeah, they're interesting issues there, and we'll get into that. We do shows, too, on information sharing when you think of this. I remember back in the Reinventing Government days, we looked at all the massive amounts of data different agencies were collecting, but they didn't really have the ability to share it. So sometimes agencies would be collecting like 2% of what they were collecting were actually using. That all the other data was useful to other entities, but there was no way of sharing it back then because of the need for speed and the massive amounts of data that we were dealing with. Let's talk about some specific strategies that are being used to manage big data. I imagine as you deal with these volumes, you're going to have to look at some strategies. Let's start with Zach Goldstein this time. Zach over at NOAA. What are some strategies that you have that you're looking at in order to deal with this massive amounts of data?
Well, strategies sometimes start with something as simple as planning. And I'd like to tell a little story about my colleague at the end of the table here and me. The day I met Adrian Gardner when he became the Weather Service Chief Information Officer, I was the Chief Information Officer of the NOAA Satellite and Information Service.
All right.
And the conversation we had on day one was about big data. We were
ahead of
looking
your time.
Well, it was a clear and present issue
Right.
for us at the time. We were looking at two new series of satellites going to be launched by NOAA, by the satellite service, geostationary satellite called GOES-R, and the NPOS satellite constellation, which is now known as JPSS.
Okay.
More on that later. The J isn't about multiple government agencies. It's about international and us, which creates all sorts of interesting big data fusion challenges. But the problem we were talking about the day we met was, so we're going to have all this data coming into the agency. How do we handle the telecommunications? How do we handle the processing of all of this so that we can actually honor the promise that we made to the American people when they funded the satellites in the first place? You've got to get improved forecasts. You can't let the data fall on the ground. It doesn't do you any good.
Right.
So 5 years later, I'm happy to say that we have a plan in place to, it's called the Ground System Readiness Program, to make sure that, in fact, we do have the investments in telecommunications and processing to make use of the data and ensure that forecasts get improved and there's no gaps in coverage and so on.
Terrific. So you're talking about planning and thinking out in the head to make sure that you don't get caught up where the volumes and the bandwidth needs exceed the ability of the equipment to process it.
And that's where you know when you're causing the issue yourself. There's other things that you do. Also, you have to worry about open standards for metadata, for interoperability. You've got to manage the life cycle of data. You've got to plan for the archiving of it and the open access of it. And you've got to think about how you're going to be able to fuse it with other sources, because you've got to make it available to the public so they can do their thing. And because of the money situation that we're all in, we have to look to other sources of big data and figure out how we're going to bring those in.
Yeah, and it's going to just keep growing. And as wireless proliferates and gets faster and faster and more broadband gets out there, it's going to make it even more interesting. Well, you brought up Adrian. Let's go to Adrian. Adrian, how about some of the strategies you're employing to manage this massive amounts of data?
Right. So we've been in this game a long time. So we've under the EOS-GIST program, which is the Earth Observing System, Data Information System. So we have these series of large data active archive centers that process huge amounts of data, and we've been doing that for years. And so there are some practices that definitely I would like to highlight. One is I think we really have sort of gravitated towards a community of practice, where we formally have actually pulled the scientists and engineers together to talk about big data challenges and big data interests. The other one that Zach kind of mentioned was looking at open standards and making sure that those can be broadly applied, and actually having a standard setting kind of body that allows us to then agilely address the issue of interoperability. So I think we've got to think about these challenges in advance of that. And as Zach has mentioned, we can't forget about the infrastructure. I have to sort of reemphasize that, because we sort of build these capabilities. The data comes off the birds, or the capabilities that are actually the sensing capabilities, and then it actually hits the ground, and we try to figure out how to then move it, right? So even moving it on center is a challenge. So not only just the wide area network and the collaboration that happens from point to point geographically, but just even on center, how do we make sure that the infrastructure is robust enough to manage that? We got to have a dialogue around cloud, and that is sort of the next big thing, I think, that's going to change the way the business practices that we use to manage big data. I'm actually generating kind of doing a proof of concept around a data storage cloud on center, to sort of prove out kind of how do we provide sort of a storage as a service for this big data kind of drive or need or requirement.
Wow, terrific. And you're right, I know it came up before, but I think the idea of standards and open sources and open architectures and things like that are going to be critical, especially with that unstructured data. So, you don't want that in proprietary formats, I would guess. Let's go to Alan Hansen at the U.S. Army. What are some of the strategies you're looking at to manage big data?
Unlike maybe some of my other panel members here, as I mentioned earlier, we have probably multiple data models that are being applied across our battlefield today, and that's been a huge challenge to us. And we also recognize that there isn't a one-size-fits-all data model that supports all these systems, these programs that are producing information. So a lot of work that we're doing today in the cloud computing environment is to look at adaptive ontologies that allow us to adapt the information based on the user's need, not necessarily based on a rigid standard, because data changes daily. The standard object models change on a daily basis. So we've went down that path. We have a lot of lessons learned to say that we need to serve that information up in a more, I say, adaptive manner for those consumers out there to use the information.
Yeah, great. And I like looking at it from consumer. I know one thing when our kids get into the workplace that we're going to be looking at it from their perspective on how you get this data quick and move things and create apps and download apps. Dr. Norris, how about over at NGA? What are some of the strategies you're looking at to deal with this massive amounts of data?
Well, as part of the intelligence community, there's a major project going on now about IC efficiencies. And as part of that, the intelligence community is actually coming up with 2 clouds.
Right. I'm sure that's easy. Everyone just gets in a room and agrees right away. Right out of the
That's
box.
right,
Yeah. Been there, done that.
But the thing about it is that we recognize that there's a lot of data that are actually in their own stovepipe systems, and that in the cloud they could actually be related together and perhaps identify new relationships that we hadn't ever thought about before. Now, one of the things that's going to drive this is the need for standards. So we are coming up with using OpenStack as a standard for the cloud, and this will allow the 2 clouds actually to be hybridized so that they'll be linked together, and that's a great thing that I think the intelligence community has done. The other thing, though, is that we are looking at a commercial provider as well as a government cloud, because what we want to do is use the commercial provider as one way of leading the work that we would be doing so that we can identify new implementations of cloud computing and actually have that impact the government cloud as well.
Right. You know, we've done a number of shows on cloud computing, and just watching it evolve, I see the evolution of like hybrid kinds of cloud environments where some will be, you know, commercially provided, a lot of the public-facing kinds of information, whereas private clouds will still maintain critical data that, you know, is important to agencies and things like that. Seems to be the model evolving. John Haddad, how about what kind of strategies over at Informatica are you employing to deal with the volumes of data?
Yeah, so what we're seeing is several agencies and organizations creating agile development teams to, you know, manage and evolve the applications that they're building on top of big data itself, but also creating reference architectures for big data to manage and deal with, of course, the growing trend of transaction data, which has been growing pretty steadily, or more structured information, but also this unstructured, or what I call interaction data, right? Social data, sensor data, machine device data, some of the examples that we've heard. And so specifically from a data integration standpoint, we're addressing some of the key challenges to help them manage this growth in big data. First off is accessing all that different types of data, right? No matter whether it's transaction or interaction, and being able to access it in different latencies. So being able to ingest the data into a large computing cluster in real time using streaming technology, or replication, or archiving massive amounts of data that you may not know what you want to do with today, but at some point you may want to use it, you know, to gather insights. And then leveraging large computing clusters, you know, such as Hadoop, which I mentioned, or even traditional grid computing clusters, which have shared highly available systems to process, you know, transform, integrate, match, all these different types of transformations, and then deliver it, if I look at it from an architectural standpoint, deliver that result set and move it back into your enterprise applications, which are then available to the masses, right? The analysts, to the different stakeholders, so that they can access the insights that you've processed through, you know, the system. So being able to access, you know, integrate, and finally deliver at any latency is key.
Yeah, great, and there's some great points there, and we're going to drill down into some of those areas. I want to get into a little bit later in the show some of the things you got to rethink in terms of technologies to deal with massive amounts of data like this, and how it might be changing some markets a little bit in terms of how you define infrastructure and so forth. I want to hear from Gary and Cameron on this topic too, but first we need to take a short break. You're listening to the Federal Executive Forum on Federal News Radio 1500 AM. Federal Executive Forum on Federal News Radio 1500 AM. I'm Jim Flyzik here with Hansen from the U.S. Army, Goldstein from NOAA, Gardner from NASA Goddard, Dr. Norris from NGA, Cameron Chehreh from General Dynamics IT, John Haddad from Informatica Corporation, and Gary Newgaard from EMC Isilon. We're talking big data and the explosion of big data and how we're handling it. Let's go. When we went to break, we were talking about some strategies for managing the massive amounts of data. Let's go to Cameron over at General Dynamics IT. What are some of the strategies that you're using to manage the explosion of data?
Jim, we've actually changed our outlook on big data a little bit to look at the cause and effect.
Okay.
So what is actually creating the big data? How do you manage that coming in? And then a lot of the important points, as Zach and Adrian have mentioned, the infrastructure now, you have to take a completely new look at how you manage your infrastructure. We've gone from static and siloed to having to be dynamic and flexible. It's a much different management strategy and technique. It also begins to drive other issues such as skill sets. How do you approach this from a skill set perspective? Back in the younger days of the explosion of big data, business intelligence skills were optional. So what are you doing with the analysis piece? What do you have to actually do with the data? They become more critical as this begins to evolve. So we're really looking at the bigger picture of data, not only what's producing it, how you ingest it, the social elements, the velocity, how you bring this in, but then really looking at that broader picture and how you solve that.
Kind of like the point Zach brought up, planning. You know, you're looking at let's plan how and look at what we need to do differently. Gary Newgaard, when we think of EMC Isilon, we think of storage. I would guess that in your strategy for quite some time is figuring out what will be our strategy going forward for managing the explosion of data. What are some of the things you're doing strategy-wise to manage this explosion?
So one of the important elements that EMC and Isilon bring to the market is trying to give the customer experience a predictable growth model. So we've all listened throughout this afternoon, the explosion of data. We're swimming in a sea of data. We have more sensors spinning off more data. And every minute, we're accumulating more data. So what we're trying to give the customer is a predictable model for how they can deal with their budget constraints. So they don't have to pay attention to the plumbing. They can pay attention to running the household. So what we all have talked about planning. And in that planning, the customers are, both government and commercial, are looking at one footprint, density, power, space, cooling, because the data centers are full. Also the operational cost of managing all that footprint. And when you take a look at the solution sets that we bring to bear, we impact every single operational area that the customers have to deal with. The other piece that's important that is being discussed here is not how we accumulate the data, but the analysis of the data. How fast can we get the information analyzed, processed, and exploited to the warfighter, to the intelligence community, to the NOAA people that are on the radio letting citizens know that they're going to be safe, that the storm is going to steer to the right or to the left. So it's the exploitation of data. So you're going to hear that word data scientist is going to be really the explosion in over the next 10 years. We can accumulate it all.
Wow.
But how do we analyze it and use the data quickly?
Yeah, it's going to be some challenge. I know when we talk cloud and data center consolidations, all that, we've brought about the idea that it could create opportunities to rethink this whole thing, because we all know with tight budgets, we're facing tight budgets for quite some time. So it's not just like adding more. We got to think about smarter architectures. What can we do? You know, how can we optimize and go to better technologies, but in the same time reduce O&M costs?
You're seeing a collaboration amongst agencies that you haven't seen in history. A cross-collaboration, a sharing of resources that never has occurred in the past.
Yeah, it is an interesting culture. Adrian, you have a follow-up on that?
Yeah, so I guess that just to kind of play off that notion, I also sit on the Information Sharing Subcommittee under the Federal CIO Council.
Okay.
And one of the charters that we have is thinking about how this interplay and beginning to think about communities around data. And so sort of almost looking at, instead of trying to come up with one standard, one approach that goes across the board, is we're beginning to have discussions around, is there a natural kind of organization in which NASA, NOAA, EPA, USGS, and other sort of environmental sharing, maybe even parts of DOE, where we would actually begin to think, sort of self-organize ourselves and bring ourselves into a position where we could actually begin to think about a standard that would flow across that particular community and actually how we would manage the resources and infrastructure around that.
Right.
I think that's a much better positioning.
Yeah, that's great.
And so and even then, if you thought about DOD and transportation, and you look at the health
Right.
sector, I think you're beginning to see sort of this opportunity where the government is realizing that we can't build it agency by agency.
Sure.
We need to begin to think about how we have shared services across agencies and begin to self-organize and provide capabilities and solutions in that.
That's great. Great
way.
dialogue, Adrian. In fact, when I was running the Federal CIO Council, I used to, and everyone's talking about reorganization, and the president's talking about reorganizing and eliminating conflicts and duplication and all that stuff. When I was there, I used to talk about we ought to look at IT as to where we can start sharing commonalities, whatever, and IT could actually be a driver to point out those areas where the government could perhaps reorganize a little bit to be more efficient, as opposed to waiting for boxes to change and then figure out how the IT matches the boxes. We're talking about the technologies. We've touched on them already, but I'd like to get into talking a little bit about this big data explosion. How is it making you rethink decisions about technology solutions and standardizing infrastructure? I mean, the volumes and the bandwidth requirements have to be, major challenges also. So let's get into, I know when I was at Treasury, when the IRS first went online way back when, I'm showing my age there, but when we first IRS went online, we were throwing servers at it like every day. I mean, we couldn't keep them. They were just another server, another server, another server. And we just wound up with rooms full of servers. Efficiencies weren't there, of course, Then we got to April 15th where the largest we hit back then, the largest volume of data ever downloaded, which of course was the extension of the time to file form, which was on that particular day. But anyway, we were just throwing technology at it. Now I'm thinking, all of you, big data's been coming, but the explosion still has to have some major impacts on your infrastructure. Let's start with Alan Hansen over at Army. Alan, how are you looking or rethinking some technology decisions just to stay ahead of this curve?
We have a lot of challenges, and it really starts with the infrastructure. A lot of big data sits at data centers on large networks. We and the Army are challenged because we live on tactical wireless networks in many cases. So to be able to serve and manage big data across these networks is going to be a huge challenge for us to have to look at. So there are strategies that we are looking at today with regards to deploying cloud computing to the battlefield. The idea of moving analytics to the edge is something that is being thought about today, whereas in the past we would move data from the edge of the battle space to the large data centers to be processed. Now we're saying, can we put microclouds down at the edge of the battlefield and be able to push these analytics down to where the data is being collected and being processed? And that, in a sense, may help us overcome this challenge of our bandwidth constraints, because the information that's being processed on the edge can actually be served up in a more smaller package as opposed to the we would call the raw or the pedigree data itself.
Right. Yeah, and I've kind of combined challenges with the technologies for infrastructure because they kind of blend together there. Let's go to Dr. Norris. Bob, how about over at NGA? What are some of the technology challenges, or are you having to rethink your infrastructure and the kind of technologies to deploy in order to be in a position to stay ahead of this curve and be able to handle all this data?
Well, we've done a few of those things. For example, one of the things that a lot of organizations find out is that when you were talking about all those servers at IRS, that maybe we're only using 20% of the capability of the server. Right. So when we virtualize that server, we then get up to around 80% utilization, which is really good to be able to do. Another thing that NGA has done is in moving to our new campus, we actually went to thin client technology. And we virtualized a number of the desktops that way too, so that we could actually reduce the footprint for that. So those are two of the big things that we've done recently. Yeah,
another hot topic. In fact, our next show is on data center consolidation and virtualization, because there's so much of it going on across government right now, and it's such a big topic.
And that's one of the things that cloud computing does for you also. It works off of virtualization.
Yeah, clearly when we talk, you don't want to go to the cloud or data center consolidation and just move your old stuff in. You want to modernize and virtualize as you go there. John, you had a comment?
Yeah. There's the obvious aspects of virtualization as relates to hardware and application virtualization, but we've also seen a big interest in extending the concept of virtualization to what I'll call data virtualization. And this is essentially building out an abstraction layer of logical data models where you're hiding the underlying complexity of the data. And you're creating data services that are reusable in a service-oriented architecture, which is much more flexible in a shared services or cloud infrastructure.
Right.
So, I think it's important to note that there's different types of virtualization.
Sure.
And by extending it to data virtualization, creating that data layer is really key. The other aspect that we're seeing, as I mentioned, is in different emerging technologies for processing massive amounts of data and storing it using Hadoop. And so what we're seeing our customers interested in is leveraging not just the traditional grid computing infrastructure for transactional, highly structured information, but also leveraging, this co-located data with each of the servers, this shared nothing architecture to process interaction data, what I've been calling interaction data, and getting those two to work together in terms of a reference architecture.
Yeah, there certainly are their share of complex challenges out there, and it's forcing everybody to rethink a lot of things here. Zach Goldstein, I saw you were nodding there on some of the comments that were being made. What are some of the technologies and infrastructure challenges that you're looking at, and what are some of the ways you're rethinking, perhaps?
So we have there's one big challenge, and there's a bunch of opportunities that come and they drive technology choices. The big challenge that you were alluding to yourself was money. At the same time as we have all these opportunities, by the availability of diverse and distributed data sources, we also don't have the resources to then reach them or even generate the data. So so you combine those two drivers, and all of a sudden you're accelerating the move to the cloud. You're accelerating the move to consolidate data centers. On the opportunity side, I'm listening to what John's talking about, and we're doing some of that ourselves, because the traditional ways of just drilling through mountains of data doesn't enable you to find anything quickly, and when you do, you don't know what it means.
Right.
So the focus now is turning toward metadata and publishing metadata, and metadata standards. My colleagues on the left, that doesn't mean anything on the radio, I suppose. We're talking about communities of interest. One of the big opportunities that we have, that I believe John Haddad alluded to earlier, was that you can go interdisciplinary. And that's a real powerful idea, that if you can disclose the metadata and work out the fact and get beyond the fact that you don't have controlled vocabularies that transcend communities, people can start doing things across disciplines. And it's an opportunity that you don't want to miss, because the societal benefits are too great. We know, for example, that there's a relationship between seasonal climate changes, I'm not talking about the big ones, but just the small ones, and disease propagation.
Right.
But those are two wildly different disciplines. But what they have in common is they're all dealing with georeference data.
Right.
So some of the things we're working on at a prototype level are how you can use geospatially referenced data across disciplines and use new technology so that in today's budget climate, you do it efficiently.
Right.
And not have to lose the opportunity just because you didn't have the money to seize it.
Yeah, good point. Very good point. Adrian, what do you think on some of the ways you're rethinking the infrastructure here in order to deal with this explosion of information?
Yeah, and I guess Zach's comments, even the comments of Gary also kind of moved me in a direction of thinking about now data management in a different way. Not necessarily from the technology standpoint, because I think, to be honest with you, I think the technology is going to be easy. It's going to sort of fall out. There are going to be technologies that work with sort of within that environment, and those that don't, and those are just the ones that don't are going to really fall by the wayside.
Right.
You've heard Hadoop mentioned a couple of times. They're sort of the leader in this space as far as being able to be agile enough to kind of really work in this area. But I would really now like to focus more on the people aspect of it.
Okay.
One of the things that I do when I go to speak to a lot of the academic institutions, I have a couple of discussions with them. I said, so one, if you look at your IT curriculum, how much is it focused on system administration with the cloud coming? And because I look at the example of the Oak Ridge National Laboratory, which houses two of the fastest supercomputers in the world, they manage that facility with 10 individuals, 24/7.
Wow.
That tells you about the ratio as far as the number of servers or capabilities that they have to the support system. The other piece of it is when we start talking about data management and metadata, so on and so forth, I think data management within our academic institutions now needs to become just like English and algebra. It needs to be taught across the board, because we're not just publishing data now in the scientific community, we're publishing it, data is created everywhere. I mean, I think it's about, the world's data doubles every 1.8 years, right?
Wow.
And so the thing that we've got to now begin to think about is, how do we catch folks at the very beginning of their academic career and build data management discipline into the way in which they structure their data, the way they think about data in general, which is a huge change in the way that our kids are taught today.
Absolutely.
And so that way, when they get into the workplace, when they get into the NOAAs and the NASAs of the world, or even EMC or any of the, on the private sector, they now are conversant in sort of data management skills. So we create sort of a baseline capability.
That is a great suggestion. You know, I think actually we should find ways, maybe get the CIO Council, someone to elevate this, to rethink the whole computer science class curriculum and information systems management curriculum, and really start focusing on these topics today that I don't think are in a lot of traditional academic curriculums now, because it's going to be, they're going to be where we're going to need the people in the future. Gary, what do you think? What are some of the
as Adrian was talking, I was thinking about my sons, and they naturally do this. They were brought up in this environment. Is it part of their curriculum as they went through college? No. But do they do it naturally? Because there's the younger generation, I hate to say that word because my parents used to say that, are so inclined to immediate access to data anywhere, anytime. And as you know, the interesting piece is this collision of things happening. You know, as the NGA likes to say, everything happens somewhere.
Right.
So the georeference is critical in all the analysis gets done. The access to data, you know, at data.gov. I mean, if you go on this website, and you're on the chair, I believe, it is unparalleled the amount of information that you can get to. This all has to be stored somewhere. So, you know, the challenge that you're saying is that we need to train our population on how to look for a silver needle in a stack of silver needles.
Yeah.
It's no longer looking for the needle in a haystack. It's I'm looking for the silver needle in a stack of silver needles.
Right.
So the analytics and the storage, you can use that one.
Yeah. Believe me, I will. Trust me.
So I think that's the way of the future. It's how do you take cost out of the model? How do you manage the data easily? The simplicity of managing the data. You talk about, you know, 20 people managing a high-performance computing center. We have people that manage 20 petabytes with just a small staff of 2 to 3 people. They can upgrade on the fly. The thing that's be really important is a sea change of how people address the data storage requirements. It shouldn't be hard to upgrade your systems. You shouldn't have to ever go through a forklift upgrade again.
Right.
That's like a root canal.
Yeah.
I went through a forklift upgrade as I had my hip replaced. It's a painful process. I would have rather had them just snap on some new parts, which is kind of how we deal with it at Isilon. We just snap on some new parts.
Right.
My hip replacement wasn't a snap-on of new parts. It was fairly invasive.
Well, we're happy to see you on the show and moving around. So glad it went over well, despite the fact that I'm sure you went through some trauma along the way. I want to hear from Cameron and John too, but first we need to take another short break. You're listening to the Federal Executive Forum on Federal News Radio 1500 AM. Welcome back to the Federal Executive Forum on Federal News Radio 1500 AM. NASA Goddard, Dr. Norris from NGA, Cameron Chehreh from General Dynamics IT, John Haddad from Informatica Corporation, and Gary Newgaard from EMC Isilon. We're talking big data and managing big data and challenges and strategies for big data. Cameron, we went to break. We hadn't heard from you yet on some of the challenges you see and some of the technologies and infrastructure ideas that you need to think through now as you're supporting agencies that are moving in this to manage big data.
Right. I want to pull a thread a little bit on what Adrian said earlier. I think if we break the problem down into manageable parts, you've got the management of the infrastructure, which we've touched on quite a bit, and how you take it from a static to a dynamic environment. But I think the intriguing point is building that capacity and skill sets, as Adrian had mentioned. You know, as young as I'd like to think I still am, I believe I'm a technology immigrant, not a native, as this generation is. And, looking at how people are now empowered to create data, right? So every mobile device out there, anything that has an IP address, you're now empowered as a person, as a citizen worldwide to create this data. So I think the real driving point for us is, again, how do you institutionalize this into the academic institutions and in people's lives, and how they change the way they think about, they create, and they manage it. When you're looking, you never know what you're looking for, right? The silver needle in the stack of silver needles, right. But you'll know it when you see it.
Very good. Well
So
put.
we have to be able to have the management strategies, but also more of the disciplines around that, right. And we need to really start institutionalizing that.
Good, thank you. Anytime we have a subject at the forum, cybersecurity is also a major issue. And when you talk about big data and massive volumes of data, some of the traditional ways, people used to say that the problem with security, it costs you three ways. It costs you money, ease of use, and perhaps some performance issues. Well, now with the massive amounts of data we're using, I think those three issues become even more critical, because we're still going to need to protect the data, but we don't want to do it in such a way that's going to impact performance. So let's talk about a little bit about that. Let's start with John Haddad over at Informatica. How are you viewing that security side of this equation with the massive amounts of data we're talking about?
Yeah, I kind of want to answer it and take off on some of the things that have been said. So you mentioned empowering people to find a silver needle in a stack of silver needles, right? We'll keep going with that analogy, right? Because I think it works. That requires you to share data sets, right? But people only feel comfortable sharing data and integrating that data if they know it's secure and they're not going to be sued or put in jail for sharing that information. And so, are the existing security models and policies going to work with some of the emerging technologies we see today, especially when a lot of them are open source projects and sub-projects. Right. And so, we're seeing this emphasis on security, and down to the data set level, down to the column and row level, down to a very granular level. And so I think what's important is, how do you first of all discover, know what's out there? How do you know what data you have and what data sets contain sensitive information? And once you discover that, how do you mask it based on permissions and privileges that your users, have been authorized to have?
Right. So again, it's going to be the planning issue.
It's the planning. It's the discovery. It's we
communities of interest, things we've talked about.
Right, and we provide some capabilities to help you auto-discover domains of information and where sensitive data lies, and then the ability to dynamically mask that information so that you can ensure it's protected as you share it and integrate it, for whatever use it might be, to find that silver needle.
Sure. Adrian, what do you think on, I know with NASA that security is paramount, and so how are you dealing with this massive, does it require you to get like higher speed encryption devices? And
I think it's just going to be a huge challenge with us as far as the amount of data and being able to secure it. So I think it's it's going to be about trust relationships, and some of those trust relationships are going to have to exist within what I would say almost is as an untrustworthy environment, given the current state of our security. And so I think we're going to have to move towards technologies that not only look at sort of, the ability to think about the number of transactions, the amount of transactions are happening, and are those secure, but I think we also need to think about how are we going to sort of authenticate the people that are engaged in those transactions. How are we going to understand the devices that are actually then that they log in from to actually conduct those transactions? And so I think it's going to be there are going to be a number of security challenges around. How do we manage it in a big data sort of environment? The other thing I would say is sort of having the ability to do real-time analysis. I don't think there's enough ability right now in this world of big data and data really in motion, real time to analyze whether those transactions are truly all secure, or is there something hiding in amongst that group of secure transactions that everybody trusts that something malicious is happening. So I think there are going to continue to be some challenges around that. we're not there yet, to be honest with you. I think
Yeah.
we are still struggling with that. I mean, you know, that it's the same discussion we're having around cloud. I think you can apply that to big data in general. So I think that is an area of emphasis and research that we need to take on.
Yeah, I agree with you wholeheartedly. We've done a number of shows here on cybersecurity, and we're talking about the fact that, in my opinion, you know, we're still somewhat in a reactive mode trying to catch up to get out in front and be proactive, because our technology, as we're talking about today, changes so fast. And just in your comments made there, we've talked about so many other areas big data actually impacts: identity management, trust, authentication, cloud, data center consolidation, virtualization, right? I mean, they're all separate topics in and of themselves. This is great, and I'd love to talk more security, but I really want to talk about the future. We've got about 12 minutes left to the show, so we're going to, what I'd like to do is just come right down the table here with sort of some closing comments about where we think this is all going. Let's share a vision for the future. What impacts do we think this is going to have on the government in the world we live in down the road? Let's start with John Haddad. John, what's your crystal ball look like?
My crystal ball, or my water bottle here. I'll call this my crystal ball here.
Okay.
So if I look into it, what I see is more data virtualization, as I mentioned, extending that concept so that we have more of a shared services, flexible architecture. I think flexible architectures is what's going to enable us to be more agile. There's clearly going to be more data moving into the cloud. That's pretty apparent to me, whether it's a private or public cloud. And, you know, if we're going to share more data, right, and in a secure fashion, that's what's going to open up all these possibilities. That's where innovation is going to occur. And, you know, so I think as we move data into the cloud, we virtualize it, we leverage, you know, high distributed computing emerging technologies like Hadoop, and then extend that at the edges to mobile devices, right? So that this information is available at our fingertips, right? Our kids are using mobile devices and are used to having information readily available. They're going to grow up and expect this. And ultimately, all this together, I think, is going to lead towards more self-service. And that self-service is what's going to create the greater efficiencies and effectivity of our government that's going to benefit all of us.
Terrific. Yeah, like more of a personalized computing kind of a world we'll live in. Alan, what do you think it looks like down the road? Where's this all going?
Jim, I will tell you, we talked about cybersecurity a moment ago, and one of the things that we were working with the intelligence communities today is the ability we call cell-level security. And essentially, we're breaking down these walls between different classifications of information.
Right.
Data will still be compartmented in certain ways, but the ability to go on with role-based access to access information from different intelligence or security domains.
Cross-domain.
Cross-domain. We bring the data all together. We mash that data up. And then I see a trend in the area of semantic processing. That's a big area that, especially in our world, where a lot of our information is unstructured. It's so we require ourselves to process that information so that we can utilize it in a way that we can exploit it and be able to serve it up. And that all kind of trickles down to where we're all going to, and that's a deep dive analysis of information. Having deep dive analysis to look at trends, to look at predicting intent, as I was mentioning early on today, these are very critical today because the information is there. It's just finding it and being able to expose it and getting it to the right user. So we see that I see a real big paradigm change in the future, at least in the military, with big data and how we're managing it.
Yeah, terrific, great comments. So Cameron, at General Dynamics IT, what's it look like, and where's this all going from your perspective down the road?
I think there's a brilliant opportunity, especially for our federal and DoD and intelligence customers. This consumerized approach to how we do data management, I think, is really beginning to evolve policy and process and the dialogue within in those sectors to really talk about building skill set capacity and analytics and how it's no longer optional but now required. We talked about the infusion of how the younger generation looks at data, how they manage data, and how we can probably gain lessons learned for one of the first few times in history from the younger generation, I think, on how we manage this. And again, just looking at a complete paradigm shift in our infrastructures, going to this dynamic type of computing model is going to be just incredible as far as the opportunity it poses.
Yeah, I think it's exciting. I think we've got some exciting times ahead, and some people haven't even thought about some of the exciting things we'll be doing down the road. Zach Goldstein over at NOAA, what's it look like down the road for you, Zach? Where's this going?
Well, there's a few things. We've already talked about some of them. For example, the benefits to society of cross-disciplinary fusion of information.
Right.
I think the solutions that we're talking about here to address the challenges and opportunities of big data will generate economic growth. There's an industry here that has to respond, and it becomes an engine for that.
Right.
And I think that's a good thing.
Absolutely. I think anyone saying economic growth these days is going to be a good thing.
Right. But there's only so much we can stimulate because we have these budget considerations,
right,
which sort of cuts the other way. So that's going to be a driver for convergence, both logically and physically, going to data centers, cross agencies, single presence on the web for multiple agencies, for multiple communities. And the other things that I think are going to be happening, one of the big changes I see is in security. Mm-hmm. We talked a little bit about that as part of the vision. The government has traditionally approached security from a controls perspective.
Right.
We have standards, and you have to implement these controls. I think we need to build upon that and be talking about new security architectures and use the very same elements you were talking about a few moments ago, the cloud, data center consolidation, as tools to improve our security.
I agree.
And here's an example. You can use the cloud to isolate the public's access to data from the deep archive, perhaps, or the deep processing that you do for life-saving operations.
Right.
So, and then last, I think that to solve this cross-discipline problem, it makes me think of what Adrian was talking about before the break about education. And the education that people need in data management isn't just about the technology of data management.
Right.
It's the sociology of data management. And if we're going to actually get to the cross-disciplinary vision of people in totally different disciplines being able to use the same data, then we have to use a cross-disciplinary solution by getting the sociologists and the linguists and the people who understand semantics
and harmonizing the data so people understand
working with the
same
technologists
way.
to solve that problem.
Good point. That's a big issue with information sharing, people understanding the information. Gary Newgaard, one would think that working for EMC Isilon, you need to think about the future to stay ahead of the curve. What's it look like down the road?
Jim, as you know, we've both been doing this a while. I notice in technology it always gets smaller, faster, bigger, you know, and interesting dynamics. I think over the course of the next few years, from a raw technology standpoint, you'll see a collision of the compute, the communications, and the storage into more of a compute cluster environment. EMC is bringing that to market with partnerships with VMware, with Cisco, and producing a virtual cloud appliance and delivering a simple to use scalable model. So taking costs out of the model. The other interesting element is how do we push the data out? So as I go back to that, looking for that needle in a thousand needles, the ability to push the data quickly to the warfighter, to the citizen, to the scientists, to help society move forward and protect the country's interests is what I think is going to see. How fast can you get it out there?
Well said, Gary. Well said. Dr. Norris, how about NGA? What's it look like down the road to you?
Well, our agency has a vision of putting GeoInt in everyone's hands, and I think that that's going to be important. And what will drive that is the need for standards, and we have a community of interest called the Geospatial Intelligence Working Group that's working on those standards right now with our mission partners. Additionally, and I think one of the things that's really important is the business analytics work that's being done. We've talked about how big data is so huge in volume. We need to think about who's using the information, how often has it been accessed, and when should it actually roll off the systems and be archived so that we don't have huge big data instead of just big data.
Yeah. Well put, well said. I like that. Adrian, what's it look like to you? Where's this all going?
So one of the things that we haven't heard, I don't think we heard it anyway, was sort of around data visualization. And I think so we may be moving towards data visualization as a service, in which analysis is only one big part of the issue. Yeah. Really now we'll be able to visualize the data more like infographics and help make sense of scaling data points in ways that we have never thought of in the past. The other one is sort of a societal kind of impact I see is I think there will be winners and losers economically. You know, I was recently out at CES and listened to the CTO for YouTube, and they boast having about 5 billion instances of videos online fully streaming. Right. And now if you look at what YouTube is doing, it's beginning to self-organize into a channel format. If you look at the broadcast community, they have 50 million sort of online streaming video as far as video content online. So what you would start to begin to say is that there's an opportunity now where YouTube could become just like your cable company, where you, instead of you waiting for your movie to come up at a certain time period, now you can demand when I want to see Red Tails, since I went to Tuskegee University. You know, I can see Red Tails now. Yeah. I don't have to wait for it to happen at 1 o'clock. I can actually see it now. So I think there are going to be some economic shifts that are going to result from a lot of this big data being available and online, and the ability for every individual to kind of create content. Yeah, that's really well put, and I'm really big on the visualization stuff. It didn't come up. You know, I have this theory that the world is going to, in computer interfaces, are going to be visual. We'll be doing visual requirements, visual design between geospatial stuff and YouTube and everything else. I think the world of text is slowly going to fade away, and interfaces will be visual and voice in the future as we move along. We've actually have done a couple shows on visualization too, which have brought up some great points. Let me do a couple quick comments to close out. We're down to just a minute or so. We've heard a lot of interesting things. One thing right off the top that I think came right out of the box is we're not dealing anymore with just traditional structured data where things are nice formats and lined up nicely in rows and columns. We're dealing with a tremendous amount of unstructured data that's coming in all kinds of formats, which creates challenges for open source kinds of approaches and non-proprietary approaches and so forth. We heard a lot about planning and looking at cause and effect. In order to stay in front of the curve, it's going to require some thinking out in front and not just waiting for things to happen. Communities of practice came up with standards and open sources, and the idea that information sharing and cloud and virtualization and data center consolidation, all those issues are intertwined and they're interrelated with what we're doing now. We also realize that we've got some money issues. You know, we're going to have to do this, but we're going to have to do it in a way that helps us reduce current baseline O&M costs, licensing costs. So we need creative solutions that allow us to deploy things, modernize, while at the same time taking some old cost out. We heard about the fact that things are happening quick. We're moving into a world where time is approaching zero. So, you know, we need to move fast and find things with the analytical tools. And we're going to need those tools that allow you to find that silver needle in that silver needle haystack. Let me close by, first of all, thanking our panelists here for taking time from your busy schedules to be with us and share your ideas for us. Thanks to the sponsors who helped, without which we couldn't do the show. Thanks, of course, to WTOP and our good friends at Federal News Radio for hosting us here. And most importantly, thanks to the listening audience out there that's listening to the show. You've been listening to the Federal Executive Forum on Federal News Radio, 1500 AM.